Alright, so right now I'm going to be doing a demonstration of a tension problem for physics. So here's the demonstration problem. Determine the tension in each cable in case A and case B. Alright, so the first thing we could do is we could quickly add gravity here, the force of gravity, and that would be Fg. Let's make this. Alright, so Fg, and let's do it over here too, Fg. Alright, so now the equation for Fg is Fg equals mg, which is mass times acceleration, or in this case, because g would be free fall, which is always 9.8 meters per second. So Fg equals, now the mass is given to us, that's 5 kilograms for both examples. So that would be 5 kilograms times 9.8 meters per second squared. Fg equals, let's do that real quick. 5 times 9.8, we get 49, and the units would be newtons because it's a force. Alright, now what do we do with this? Okay, so let's label this T real quick, and of course we're going to be starting with the first case. Alright, so the thing is that T would be going in the upward direction and the force of gravity would be going in the opposite direction, so they're going to be canceling each other out. Now how are we going to do this in an equation? So first thing we could do is we could do Fn, which is normal force, and use the equation for that, which is Fn equals mass times acceleration. Now because the objects, they're stationary, they aren't moving, they're in equilibrium, so that would be Fn equals the mass, which is still 5 kilograms, times the acceleration, but because it's not moving, the acceleration would be 0 meters per second squared. Therefore Fn would equal 0 newtons. Alright, so now we could make an equation out of the stuff that we have given. So 0 newtons would be equal to the force, well rather it would be equal to tension minus the force of gravity. Now why would this make sense? First of all, it would be 0 newtons because the object's not moving, it's in equilibrium, so the forces, they would cancel each other out. Now forces that cancel each other out are tension, which is going upwards, and the force of gravity, which is going downwards. So that's why this equation would work. So when doing basic algebra, we could add Fg to each side. Fg equals T. We know Fg, which is 49 newtons. So T equals 49 newtons. Now that's for the first case. So now for the second case, the only difference here is that there's 2 ropes. So we could use the same equation, which would be Fn equal, but because there's 2 ropes, there would be T1 and there would be a T2. Let's label that real quick. T1 and T2. Alright, so it will be T1 plus T2. Now because these two forces together are canceling out the force of gravity, it will be T1 plus T2 minus Fg, because they're going in opposite directions and creating an equilibrium. Now Fn, we know, is 0 newtons, equals T1 plus T2 minus Fg, which is 49 newtons. Add 49 newtons to each side. 49 newtons equals T1 plus T2. Now in this specific case, T1 and T2, they would be equal. Now this won't always work. Most of the time it wouldn't, but in this specific case, it would. So we could just simplify this and make it equals 2T, because they're equal, so there's just basically two ropes with equal tension. So now when doing basic algebra, we divide both sides by 2, and what would that be? For 9 divided by 2, we get 24.5 newtons equals T. Box our answer. So for case A, the tension in that rope would be 49 newtons, and for case B, it will be 24.5 newtons per rope. Alright, now here's the second problem. Two identical strings making an angle of 30 degrees with respect to the vertical support a block of 15 kilograms. What is the tension in each of the strings? Alright, so the first thing we should do is label everything that we have given. So this string is T1, this one is T2. The mass of the object is 15 kilograms. And both of these angles are 30 degrees each. Alright, so after this we should use the equation Fn equals ma. That will give us the normal force. Because the object isn't moving, the acceleration will be 0. So the mass is 15 kilograms and the acceleration is 0 meters per second squared. Therefore Fn would equal 0 newtons. Alright, now for this one, we should also set an x and a y. So and this would be T2y, this would be T1y, and these two would be T1x and T2x respectively. Alright, so we understand that the force of gravity is active, and that's going in a downward direction, and the tension of the ropes will be going in the upward direction. That'll give us the normal force because the object isn't accelerating. So that would allow us to set this equation equal to 0 newtons. So that would be T1 in the y plus T2 in the y, because they're both acting in the same direction, minus Fg, because that's going in the opposite direction, would equal 0 newtons. Now we have enough information to find Fg using the equation Fg equals mg. Fg equals the mass, which is 15 kilograms, times the acceleration, which is 9.8 meters per second squared, and that would give us Fg equals, let's calculate that, that gives us 147 newtons. So right off the bat we could add Fg, 147 newtons, to each side. So we get 147 newtons equals T1y plus T2y. Now the key word here is identical, so that shows that T1 and 2y, they're equal. So therefore we could simplify this to 147 newtons equals 2Ty 2T. Alright, so now in order to find the tension in each of the ropes, we could use the y component, and we could replace that with sine of the angle measure. And in this case, so these two angles are 30 degrees, so that means the angles adjacent to that will have to be they'll have to be complementary. Basically they'll have to add up to 90 degrees. So 90 minus 30, that would give us 60 degrees. And we could plug that in here, so we get sine of 60 degrees. And over here we could divide both sides by 2. So that gives us 73.5 equals T sine of 60. And then we could divide both sides by sine of 60 to isolate the variable. So if we do 73.5 divided by sine of 60, we get 84.87 newtons equals T. So that's the tension in each of the ropes. Because they're identical, they would be the same.